Okay, so we're dealing with negative exponents now, and we got some different ways of looking at this. So we're going to jump in here. Go ahead and try the first problem, see what you come up with, and then hit continue to check your work and your answer. So the problem wants us to rewrite the following so there are no negative exponents. And we see we have a negative exponent right there with t to the negative third. So what we want to do is see how do we rewrite this so that t to the negative third, we get rid of that negative exponent. Well, the 3h to the fourth we don't have to worry about. Those don't have negative exponents, so we're good. And what we have to remember is that a negative exponent, if this was t to the negative 1, this is the same thing as 1 over t, or t to the first. So basically, the negative exponent tells me that this thing flips to the other side of the fraction. Now, we don't actually have a fraction, but if we think of the original problem as all being over 1, we do see that we could write this as a fraction. So that t to the negative 3 just plops down and becomes the bottom, the denominator of that fraction. So this would turn into 3h to the fourth t to the third. All right. The second one, it says simplify the following so that your answer is not a fraction. So we want to simplify this and get rid of any remnants of a fraction. Go ahead and try it, and then hit continue to check your work and see how you did. So the first thing we would do is we'd say, okay, I see I have 4 divided by 2. That's just 2. Now, from what we learned about dividing exponents, I see I have x to the 5th and x to the 7th. And what do I do with those exponents? I subtract, right? Division, quotient rule for powers, we subtract. So that'd be x to the 5 minus 7. And then we have our y's that we need to look at. And that would be, these would turn into 7 minus 4. Remember, it's always top minus bottom. So 7 minus 4. And here we would just simplify. We would have 2. 5 minus 7 is negative 2, so x to the negative 2. And then y to the third. And there is that expression simplified so that it is not a fraction. So the third one here, it says, what would be another way to write the following expression? 3y to the negative third, k to the fifth. All right, so see if you can find another way to write this. And the trick is, there's always something you can do with negative exponents. All right, so try it on your own, click continue when you're ready to check your work and your answer. So the other way to write this would be 3k to the fifth on top of a fraction, and the bottom of the fraction, that negative 3 tells us we can rewrite it as a positive and just put it on to the bottom of the fraction. So y to the third on the bottom. All right, the last one for today, is to simplify the following. So we're going to be combining all of our nice little rules here and see what you come up with, all right? Try this on your own. I know it looks difficult, but I know you guys can do it. Try it on your own. Click continue when you're ready to check your work and your answer. So the first thing we would do is let's just focus on the top here. I see that I have 6 times 4. Okay, 6 times 4 is 24. So that's the top. The bottom, I see I have 2, 3 being multiplied. That's 6. So I know that when I get rid of all the numbers, I'm going to have a 4 left. So let's put that 4 down here at the bottom. And now let's focus on the variables. I have w to the third on the top and w to the fifth on the bottom. So that means I can subtract their exponents. So I could have 3 minus 5. And that would be w to the negative 2. And then the k's, I have k to the 6th on the bottom and k to the 9th on the top. So that would be k to the 9 minus 6. Remember, always the top exponent minus the bottom exponent. And they have to have the same bases. That's why we're only dealing with the k's. So we get k 9 minus 6, which would be k to the third. So that's one possible answer. You could have also wound up with 4k to the third divided by W squared. So you could have rewritten it one of these two ways, with either the W having the negative exponent, or the bottom putting it as the denominator of the fraction, making that 2 positive. Now, the one thing you always want to make sure is that you used everything in the original problem. So we did the 6 times 4, we did 2 times 3. That's where these came from, right? We used the W's, we used the K. So there's nothing left over that we missed in the problem. So that's a good habit to get into with these types of problems. Make sure everything's accounted for in your answer. Okay? You guys go ahead and move on to the practice. Try the problems. Call your teachers if you need help, and we hope to see you guys in the live lessons.